Okay, today we're going to start looking at some quadratic functions and models. We've looked at some quadratic functions. That simply means that you have some x squared, or it could be y squared, but it's going to mostly be x squared here. X squared, so it's the highest exponent is a 2, so that makes it quadratic. And remember that the graph of a quadratic is a parabola. That's that U-shaped thing, either opening up or down depending on the sign of the x squared. So, most of what you're going to see today is just a repetition of some things that we saw in the last chapter. Okay? So you get a chance to look back at some of those things that we've already done. So it'll be a bit of a refresher with a few new details added in. Okay? So let's begin by just going straight to the homework and seeing what they're going to ask you. So first thing, it says match the following equation with the description of the parabola, that is its graph. So all you're going to be doing is you're going to be looking at the function and remembering that we have shifts and transformations. So what you need to know here is that from those shifts and transformations, you can get every piece of information that you need to determine the vertex and if it's opening up or down. Okay? So, what we have, is because it's in this specific format, notice that it's in a parentheses, then you have your x plus, oops, sorry, I'll fix it, some h, where h is just any number, right? So y plus 4, y minus 8, whatever, who cares, plus some other number, we'll call it k, and remember that you can have a multiplier in front, which is the a right there. Now sometimes that multiplier is just a sign. It could be negative, and that means that if it's negative, that means it's going to be changing the direction, so opening up or down. A couple of things you need to know about this. First of all, remember that anytime you're dealing with this h, if you take it away from the x, it's going to change the sign. So right now it looks positive, but if you take it away from the x, it's going to be a negative. Keep that in mind as we go. It's going to be incredibly important for you in this particular chapter. Okay? Now, let's look at a couple of things that we can do. First of all, we can look at this equation in this format, right? Notice it has to be in this format. And we can first find the vertex. Remember, the vertex is that point where the graph changes. It curves, so it stops going down and starts going up, or vice versa. And the vertex is always the point h, k. So when it's in this format, you can literally just read the point of the vertex. Okay? Remember that a is that stretch that we were getting. And it also will tell you whether the graph opens up or down. Up if it's positive, down if it's negative. Okay? Now, there are a couple of other things that you can tell from here, from this piece of this equation in this form, function in this form. And one of them is something called the axis of symmetry. Don't freak out about it. It's very easy. The axis of symmetry is an equation, and it's simply x equals whatever your h is. The axis of symmetry is an imaginary line that cuts the parabola in half. The parabola is exactly the same on one side as the other. It looks like a mirror image, so it's actually opposites. But so you get a mirror image on one side of the other. So this axis of symmetry is a line, an imaginary line, that cuts it in half. Okay? So we have all of those pieces. We have a couple of other pieces that we need to talk about when we're dealing with these as well. So let's clear this so we can put those other notes. Now, we're also going to be finding the Y-Intercept, and it's usually singular. There's usually only one for a parabola, but it's quite possible there could be two if the if the graph opens sideways, which we've seen a couple of those that do that. Now, intercept simply means where the line crosses the y-axis. And so it's just a point on the line. Okay? And the easiest way to do that is simply to read the point. Okay? And we'll look at some examples of that so you can see. Just read it off of the graph. We will also be asked occasionally, I don't know how many of these, to find the x-intercept, or intercepts plural. There usually are more than one for these because, remember, it's a parabola, it opens up. Now, they're not always more than one. Sometimes there's only one. Say, for example, it's a very low graph. And sometimes neither one of these things will exist. It may never cross the y-axis, or it may never cross the x-axis. Okay? So that's where it crosses the x-axis, which is the horizontal one. So make sure you remember which one's which. Okay? So we have these two things that we're going to be sometimes asked to find. So make sure that you remember those. All right? We're also going to have to remember that we need to find the domain. Remember, the domain means you're reading it from left to right. Okay? That's every possible x value. So that means you're going horizontally from left to right. And remember, the other one is range. And that's what's happening from the bottom up. And remember, those are all of your y values, every possible y that it can be. Another thing that I want you to remember is that these are they ask you for these in interval notation. And if you'll remember, some of us didn't do that right before. So if it's an interval notation, remember, if it's a number, that's a hard stop. So it gets a bracket. But if it's infinity, that's a soft stop. So it gets a parentheses. And the key to knowing when to do that is this phrase right there. And it'll ask you, remember, always look at the blue writing when you're enter your answers, because it gives you a lot of information that you can use to answer the question correctly. Okay? Now, I think that's everything they're going to ask you. There may be more, but if there's more, we'll put some more notes in and make this work for you. Okay? So let's get rid of that and answer the question for this particular function. Well, remember that we have to find our h and our k in order to know the vertex. H is the first one, and it looks like positive 9, but remember, that means we're actually going to use negative 9. Then the transformation, so look at the positive 8, so it's positive 8 is our k, and that's all there is to it. That's the vertex, right? Now, if you look in front of the parentheses here, there's no multiplier, which means that it's simply a positive, right? So it's positive. So that tells us that it's going to be opening up from that point. So this particular parabola has a vertex of negative 9, positive 8, and it opens up. So the correct answer would be B, right? So let's make sure I got that right. There you go. Now, that's all they ask for in that particular question, but in others they're going to ask you for a series of questions. Let's look at this one. X plus 8 squared plus 9. So remember, we need our, oops, get to the drawing mode. We need our HK, where H is simply the thing that is inside the parentheses, but remember you're going to change its sign. Make sure you get them in the right order, and then the 9. Okay. There is nothing in front of the parentheses, which means it's positive, which means it's going to be opening up. So our vertex is negative 8, 9. And so that happens right there at E, negative 8, 9. But it also happens on G, negative 8, 9. So, but we need to make sure we have the second part, which is that it opens up. So that means E is our answer. And there we go. And again, that one didn't ask us any other questions, so we'll move on. Here's another one. Now, remember we need our HK, so it's -9. Whoops, let me get back to drawing mode. It's -9 because when you pull it away from the x, it changes its sign. +6. And if you look in front of the parentheses this time, you'll see a minus, which indicates that this is a parabola that opens downward. So there's our vertex, -9, 6. Here it is, -9, 6, and then it says it opens down. So our correct answer this time is B. So you're hoping for lots of these on the test, I know. Doesn't happen. Okay? All right. So we've looked at how to find some of that information. Now what we're going to do is look at some other information, and it's based on things that we've done before. So these shouldn't be new to you. Just remember which one, domain and range, which one is which, and remember that you're typing your answer in interval notation. Okay? So when you're thinking of the domain and range, remember that simply means the domain is every possible x value. And if it's a parabola opening up or down, it doesn't matter. If it's a parabola opening up or down, then the domain is always the same. -infinity to +infinity. Okay? Because it starts over here and ends over there, but that U shape means that it opens wider and wider and wider and wider and wider and wider. Remember, you're going down here and coming up, right? So it starts over here where everything's negative and goes over, infinity, and then it goes over here to where everything is positive. Okay? So it never changes as long as it's opening up or down. Okay? And remember that infinity, whether it's negative or positive, always gets those plain parentheses in interval notation. Okay, there we go. Now, the range, however, are all of the the y values, right? So when you're talking about range, you're talking about y values. And remember, we're reading it from the bottom up. Yeah? So let's enlarge this graph so that we can see where it starts. And you'll see that as you're reading from the bottom up, so we're going up from down here, this graph doesn't start until we hit that line right there. And that line, if I hadn't covered it up, that line starts at -4. So that means that's your beginning point. So it's -4. But notice that it goes up all the way to the edge of the graph, which means it goes up infinitely. So in a sense it's going up, that's positive infinity. Now, but remember, we're doing interval notation here. Infinity will get that soft parentheses landing, but remember -4 is a hard landing. That's a number where it actually begins, and so that's going to get a bracket. So as you put this into put your answer into the MATLAB, make sure you're using the correct symbols. So when we type that in, make sure again that you're using the brackets, because -4 is a hard landing, and then infinity will get the plain parentheses. Alright, so interval notation is the key there. Give the coordinates of its vertex. Well, remember the vertex, the coordinates from the vertex can be simply read from the equation itself. The vertex is that point HK. Well, it's +5, so that means it's going to be a -5. -4 stays not -4. So there's your vertex. It's simply -5, -4. The same thing that we did a while ago with the first 3 questions. So let's type that in. Remember, it says type it in as an ordered pair. So remember, an ordered pair has to be inside parentheses. So that was -5, comma, -4. Make sure you close your parentheses. You can use the templates down here, but for some reason that doesn't like me, so I'm going to just type them in, which means it's going to take a lot longer. Sorry. Okay. Then you want the equation of the axis of symmetry. Remember, the axis of symmetry simply means that h value. It's an imaginary line that cuts the parabola in half. So looking at that, if you look at this parabola, you'll see that there's a line that cuts it in half that goes right there. Well, that line is always going to correspond with that h value. It's at -5 in this point. It's between -4 and -6, so that's -5. Okay? So, and it's always the h value when it's in this format, which is the only format they're going to give you. So -5 is our axis of symmetry. Don't put it in parentheses or anything, just a number. Okay? The y-intercepts, remember y-intercepts is where it crosses the y-axis, right? And if you look at this one, here's the y-axis. Doesn't look like it crosses the y-axis here, does it? But it does. Remember that these things eventually just keep spreading out and spreading out and spreading out until you do actually cross the y-axis at some point. And generally, usually, we could just read this from the graph, but you'll see that this graph doesn't cross the y-axis, so we're going to have to do a little mathematics to find the y-axis. But it's easy to find, okay, because remember, if you're on that y-axis, that means you haven't gone right or left any. So that means that the x value has to be 0. Okay? So, if you're looking for the y-intercept, it's going to always be the point where x equals 0. Because in order to be on that y-axis, you can't go right or left any. So all we have to do is plug in 0 into our function and simply find f of 0. Now again, usually you can just read it from the graph, but this time I can't see it. So it's going to be f of 0 equals 0 plus 5, quantity squared, minus 4. 0 plus 5 is just 5, and 5 squared is 25, minus 4 gives us 21. So it's the point 0, 21. So even though you can't see it on the graph, eventually that thing would cross the y-axis. So let's type that in. Remember, it's an ordered pair, so that means parentheses always. Okay, so parentheses 0, comma 21. Close your parentheses and check your answer. There you go. Okay, so you might have to do the math, but remember, if it's going to be on the x-axis, it has to be where y equals 1, which is this. X equals 0. I'm sorry. Why do I get confused like this sometimes? And then, so remember, the same thing happens with the x-intercept. We're going to have to find those too in some of the problems, so you can find those mathematically. The only difference is that instead of x equals 0, it would be y equals 0, because you can't go up or down any. So we'll look at these. But in this particular case, we can easily read these x-intercepts. Remember, they want you to type an ordered pair and use a comma to separate them as you need to. So let's blow this graph up a little bit so that we can read that easily. There are two of them. Doesn't matter the order that you put them in. There's one right there and right there where it crosses that x-axis, right? Remember, it's always x comma y. So here, to get to this first one, I wouldn't make a red dot for that. That's where we're going first, right? We're going to use that one first. So to get to there, we had to go left 1, 2, 3, 4, 5, 6, 7, right? So the x value is -7. But notice that when we're on the x-axis, we didn't go up or down any. So that means the y value of it is going to be 0. And that y value of an x-intercept is always going to be 0. Okay? Now, we'll do the second one, the black dot. We have to go left 3, so that's -3. But we didn't go up or down any, so that means 0. So our two intercepts are -7, 0, and -3, 0. Notice that I've separated the two ordered pairs with a comma. If you don't, it will count it wrong. So be very careful about the notation that you use. So let's type those in. Parentheses, -7, comma 0. Close our parentheses, comma, parentheses, -3, comma, 0, close your parentheses. Be careful with your typing. Make sure you're getting them in exactly right so that they don't count it wrong because you've done some typing error. There you go. And the question is complete. So that's everything they want. Okay? Now, I'm going to look at this one, and what I'm going to do is I'm just going to show the completed answer. I don't want to go through every single detail. I just want to make sure that we have everything that they ask for. The domain and range, remember the domain for any quadratic function f of x is always negative infinity to positive infinity. The range, this time it opens downward, so it doesn't start here at +3. Remember, you're always reading from the bottom up, and if it goes down forever, here, that means that it starts at negative infinity. But it doesn't go up forever. It only goes up until you hit that line right there, which is where y equals +3. So there is your range. So be careful which way it opens because it's going to make a difference where it starts. Remember, when you're talking about range, you're always going from the bottom up. The coordinates of the vertex, that -6 gives you +6 and 3. So +6, 3 are the coordinates for the vertex. All right. So there we go. Then the axis of symmetry, it's always just your h value, in this case, which is 6. Pull that out a little bit. Okay. The y-intercepts of the graph simply means where the graph hits the y-axis. And if you look at this, you can't do this without doing some math. So all you need to do is make x equals 0 and evaluate the function where x equals 0. So let's pull that over. Maybe. Pull that over and then evaluate the function for that particular number. So we're finding f of 0. So it's -3 times 0 minus 6 quantity squared plus 3. Do the inside of the parentheses first. 0 minus 6 is -6. -6 squared is +36. Still times -3 and add a 3. -3 times +36. What does that give us? 18. -108 plus 3 gives us +105. Oops, -105. Sorry. Use your calculator so you don't make the same errors I did. Okay, so you'll see where they got that point of 0, -105 for the y-intercept. Okay, generally you can read it, but this time the graph wasn't big enough. And then the x-intercepts, again, those are the points where the graph is crossing the x-axis. You can just read those straight from the graph, 5, 0, 7, 0. Okay, so same information that time, just a different equation. Notice the -3 in front, that's what made this one open downward instead of open upward. When we look at the function, this -3 in front is what made it open downward. Okay, let's see the next problem. Next thing is the same thing: domain, range, vertex, axis of symmetry, intercepts, etc. Again, you're going to have to do a little math to find the y-intercept because it's not crossing y in this one, but it does eventually cross y, no matter how much it doesn't look like it. Okay. All right, here, vertex, axis, domain, range, and then they ask you about the largest open interval in which the domain is increasing. Remember, increasing means that it's going up. Now, this is interval notation, right? But the graph doesn't start or stop at these points, so you're still going to get that soft landing. This is just talking about where it's curving, so be careful about interval notation. It's a little funny about, remember, a hard stop means the bracket, but everything else is a parentheses. So let's look at the graph so that you can see the intervals over which it's increasing or decreasing. Make it bigger and you can really see. And you'll notice that it turns right here on this little imaginary line, which happens to be the axis of symmetry. So And on this side of it, it's going up, and on this side, it's coming down. Because remember, you read it from the left to the right. So it's decreasing over here, right? And on this side, it's increasing. Make sure you're putting the right one in the right spot. And the point of change there is where x equals -5. Okay? So, again, make sure you're careful about which one you're looking at, increasing or decreasing, so you get the right one. Because this one, decreasing comes first, then increasing comes second. But in the problem, they want increasing first, right? Which is what actually comes second on the graph. So it's at -5, it starts to increase, right here at -5, and then it increases forever. So that's the point. That's -5, comma, positive infinity. Okay? Then, where it's decreasing, that's all of this area over here, so that means it starts decreasing at -infinity, but it stops decreasing when it hits -5. But again, that's a soft landing, not a hard landing. So no bracket. All right? So that's something we've done before, but we haven't done it in this particular instance where it's a parabola. Okay? Here's another one. This one's opening down. No big deal. Graph the quadratic function and then give its domain. So we're going to have to actually graph these before we can do that. And remember, to graph a parabola, you can find the vertex, right, using the information from the equation, and then simply find f of some other number, and it makes no difference what number you use, f of some number, to be able to do this. Now be careful though, because if you look at the graph here, you'll see that this graph doesn't exist above this point, where that turn is. So if you chose x equals 0 to find out what the other where the parabola is, then you're not going to be able to find that point. So really, the increasing or decreasing function, is going to tell you, the vertex function is going to tell you that we have to choose numbers below that point in order to make it work. Now, you could choose 0. What's going to happen is it's going to come down here. So be careful when you're choosing numbers. Now, if you choose 0, also on this one it's a fraction. It's going to give you some fractions. You can do fractions. It's not that big of a deal on your calculator, but it doesn't really do you much good. So let's look at a number that might make your life easier. So if you want this number to get rid of this fraction, we need to make sure that whatever number you get in here will divide by 4, because multiplying by 1/4 is the same as dividing by 4. So whatever number you get in here needs to divide by 4. So that's easy to do. Just make this turn in. So I don't want to use x equals 0 because I'd give you a 3, and when you square anything, it's still going to divide by 4, right? If you have a number here divided by 4. So why don't we choose x equals 1, because 1 plus 3 is 4. And if you use that little trick, it'll always eliminate your fractions. So don't use 0, let's use 1. Okay? Now, ready? Because the domain is all infinity, so you can choose any x value. Now, not every y value is going to exist, but every x value will. So we plug in the 1, so that gives us 4 here. And 4 squared, that's a 2 up there. 4 squared is 16, right? 16 divided by 4, the negative times the positive is negative. 1/4 times 16 is the same as 16 divided by 4. So that's going to give you -6. Okay? Now if I have another point on the graph, then I can simply plot it to graph this function. So let's look at what that looks like. We know the vertex from just reading from the equation. I don't know if it'll let me use the, let me take the completed answer off. Now it's going to change the problem a little bit, so let's just go through this one. The vertex here is going to be -2, -1. The point -2, -1, right? Just reading straight from the function. Then it's going to ask us to graph it. So let's click on our graphing tool. we know that this is a parabola. We know from looking at this thing, so it's a parabola, right? Now, we're going to plot the vertex. Click on the graph to plot the vertex first. We know the vertex is -2, -1, right? So that's -2, -1. It's right there. Then we can find a value for that function, right? This time, if you'll look, the function has -1/2 in front. So we want that number inside to divide by 2. So if it's -1/2 times x plus 2 squared minus 1, I want this thing in the middle here to turn into something that will divide easily by 2. So the couple of choices. The easiest one is to choose 0, because 0 plus 2 is 2. But you could also choose 2, because 2 plus 2 is 4, which will also divide by 2. Just as long as it divides by that 2, you're in good shape. Okay? So I'm going to go ahead and put in 0 in place of x. So 0 plus 2 is 2. 2 squared gives me 4. Negative times positive is negative. Half of 4 is 2. So that means that we're going to get -3. So that's the point 0, -3. And that will give us another point on our graph. Click the graph on a plot on a point on your parabola. So we chose -3, right? You see it already starts bending. We chose 0, -3, which is right there. And remember that it gives you, see in the yellow, it tells you make sure you're on the right point. So click on it, and that will draw your parabola for you. Notice it already opens down because you clicked on the right point. It has to be, and you knew it was going to open down because of that negative, so you'll know whether you got the right answer or not. Let's check. There we go. Okay? Now, then you can go on, get the axis, etc. So I'm going to click on Show Completed Problem, which is going to change all the numbers, but it still shows the same information. Okay? All right. So graph it just like we did in the last section. 9 is just the same. Okay? But if you look at this one, this time the function is a little different. The function value isn't given in the same format. We don't have that parentheses. So that means that, so if you look at the function here, the function is f of x equals -3x squared minus 30x minus 72. So this time it's in a slightly different format. We don't have that parentheses. And if we don't have the parentheses, then we can't simply find the vertex by reading the 2 points. So we're going to have to look at a different way of finding the vertex for this one. Okay? And so let's hold on a minute and let's get some notes down to learn how to find the vertex here. So if you look at the Help Me Solve This or the View an Example or the video, what they're going to do is they're going to try to get you to use a method called completing the square when you start with this type of format. When you start off with this, they want you to get it into that x minus h squared plus k format, right? And completing the square is perfectly fine. It's very easy and simple to do once you understand it. But we already have a method that we can use instead of working out a new method called completing the square. Now, mathematicians will tell you that completing the square is so elegant and it's just the way to go. But we can do it another way with something that we already have. Because if you'll remember back in the first chapter, which everyone loved when we were solving all those equations, one of the ways to solve a quadratic equation, and remember this is quadratic because that x squared, is to use what's called the quadratic formula, right? So you'll remember the quadratic formula. It never goes away, kids, so you have to memorize it. You have to be able to use it. And remember, it's simply, the quadratic formula says that x is equal to -b plus or minus the square root of b squared minus 4 AC all over 2a. Now, the good news here is that we're not going to use the entire formula. We're only going to use a little piece of it to be able to find that x value. And oddly enough, what's really weird about this is that the x value of the vertex, whatever the vertex of the parabola, is always just that minus b over 2a part. So all we need is this bit of the quadratic formula to be able to find the vertex. Okay? We'll look later at some ways where we can use this bit to do some other things, but right now we're just going to be interested in the vertex of the parabola. It's just that minus b over 2a. Okay? So that gives us the x value, but it doesn't give us the y value. Or does it? Kind of does. So what we're going to do is, whatever that x value is, to get the y value, we're just going to find f of that x value. Which, and remember, that simply means to plug it in and do the math. So whatever your number you get when you do that minus b over 2a business, you plug it into the equation or the function, do the math, and that'll tell you your y. Okay? So let's look at how that works when we're dealing with this particular one. Hopefully you can see I'm writing all over, I know, but I don't want to go to a different page. Now, don't know why they give you such big numbers. They're just so nice to you for that. F of x equals, here are things. Remember, all we need to do is find the vertex first. Easy. So first we need to do opposite of b minus b all over 2a. Remember, b is simply the second term, and it's only the numerical coefficient, the number in front. Okay? So it's negative 30, so that's negative 30, but remember we want the opposite of that. So minus negative 130 over 2 times my a, and my a in this case is that negative 3. Okay? Well, minus 30 is positive 30. 2 times negative 3 is negative 6. And 30 divided by negative 6 is negative 5. And so that's where they're getting that negative 5 as the x value of the vertex. Okay? So that's the x value right there. Now all I have to do to get the y value is find f of that number. So f of x will give you your y value. So let's plug that one in and see what happens. Clear that. So it's f of negative 5. So that's negative 3 times negative 5 squared minus 30 times negative 5 minus 72. Negative 5 squared is 25. Negative 3 times positive 25 is negative 75. Negative times a positive, positive. 30 times 5 is 150 minus 72. Right? Negative 75 plus 150 is positive 75. Minus 72 gives you a 3. So that is the y value. And if you look, we got exactly the same numbers that they got. So it's really easy to find the vertex when it's in this form by using those pieces of the quadratic formula. But you're simply going to have to memorize it. Now, that's called plug and chug. Mathematicians don't like plug and chug. But unless you're moving on to become an engineer or something, plug and chug is just fine for us. Also, having so many different methods to do the same thing is not always that advantageous. So, whichever you want. If you love the elegance of completing the square, then go for it. If you want to pass college algebra to get your degree, and be able to do it anyway, because you'll notice I got the same answer. So, elegant, not elegant, I got the answer. So, either way you want to do it, it's fine by me. But you've got to be careful, because if you do it this way, you can check your answer, but they won't do it this way. Okay? Now, if you want to plug in and just Google finding the vertex using the quadratic formula, you'll see that they show you exactly what I just showed you, so you can practice that more if you, I don't know, you just want somebody else to tell you how differently. Okay, so finding the vertex is a little different. Now everything else, the axis, graphing it, everything else stays the same, no matter what format they give you. It's just the vertex. You can't just read it straight up from the function when it's in that format. Let's see what's next. Number 10. The figure shows the graph of the quadratic function. Use it to find the minimum value of f of x. Well, look at the graph, and you'll see that the graph bottoms out right there. Okay? So the minimum value is simply the bottom of the graph. Okay? Now we're talking about top and bottom, so that's, to me, not side to side, so that sounds like a y value. So the minimum value is simply the y value of the vertex. As far as it goes down before it starts going back up. You're also going to be asked, if the graph went the other way around, you might be asked to find the maximum value. Well, the minimum value is when it's going down, up or down like this, when the parabola is opening up, I'm sorry. The maximum value is when you have the parabola opening the other way. So you see this one goes up to the top. So that's simply the y value of the vertex. It doesn't matter. So it doesn't matter which one you're being asked, minimum value or maximum value. It's just the y value of the vertex. Okay? You get a minimum if it opens up, so it bottoms out. You get a maximum if it goes up, if it opens downward. That means the vertex is at the top, or the maximum point. So just read it here, and they even conveniently tell you the vertex is negative 5, 5. That means that the minimum is positive 5. Okay, so couldn't be much easier on this one because they graphed it for you. All right, let's see what they graphed it for you, and they told you the minimum. Now let's see what number 11 does. Figure shows the graph. How many real solutions are there to the equation f of x equals 1? Okay, in other words, does f of x equals 1 exist? And if it does, where? Okay, and how many times? So what we're going to do is we're just going to remember that f of x equals 1 means that y, remember that f of x is the same as saying your y. So they want you to say, how many times does that line cross if y equals 1? Okay, so y equals 1 is what we're looking for. Well, y equals 1, if you expand the graph, y equals 1 right there. So let's draw a little dotted line there. Be careful. They love to do this to you. They count in twos, right? If they're asking for an odd number, they'll count in twos. Don't let that throw you. So what we have is, we have that line right there is y equals 1. Well, what do you notice? Do you notice the blue graph? Does it ever cross that point? No. So if it never crosses, then that means there are no real solutions to that number, for that particular number. Okay? Now, I want to close that and ask you another question. What if they asked you, what if it was f of x equals 10, for example? Well, all you need to do is find out where that happens. It happens right here. And that means that it crosses it there and there. So in that case, if it was 10, then there are two real solutions. In other words, it happens twice. So you'd click on 2. Okay? Now, parabola, not going to have 3, right? Because you just have 2. It's just a curve. But it can definitely have 2, so don't think it can't. Okay? All right, let's see what the next one is. I hope y'all enjoyed me doing all your homework. the quadratic function whose graph matches the one below. So in other words, I need to make the graph, find the function if I'm given the graph. Okay? So let's look at how we can create the function if you have the graph. And you already know parts of it, right? We already know some of the bits and pieces. Now let's look at how we can find the rest of it. So here we go. So we know that that general form of the one where it's completing the square, right, looks like that. So remember that h and k are the x and y values from the vertex. Be careful which one. So this is the x value and this is the y value. But remember, when you do that, you have to change, you're putting it back with that x, which is going to change the sign. Remember, this A tells you whether it's opening up or down. If it's opens up, that's positive. If it opens down, it's negative. Well, they're not going to get too mean to you and give you one where it doesn't follow the pattern. So notice this one is opening down. That means that your A is a negative. If it was opening up, that means that would be a positive, so you wouldn't write anything. Then it's going to be x, but remember it's x minus your h. So your h here looks as if it's -2, but remember when you put it back with your x, it becomes +2. Okay, so don't forget to change that sign. And then your k is +3. And so there is the function for this particular graph. So you're just doing the same thing that you did, but backwards. Find those 2 points from the vertex. So let's type that in just to be sure that I got it right. So it's minus x plus what's that, 2? Close the parentheses, plus, then our vertex, the other point was 3. Oops. Oh, I forgot to square the thing, but there you go. So, right, I left off the square on the function, so make sure when you're typing it in, put it in parentheses, then raise that parentheses to the power. So let's look at, okay, and they give you a way to do that by giving you the superscript to put in the exponent. Okay, so make sure you don't forget the exponent. Let me see if I can just retype that. Putting in that exponent. Click. There we go. Just go back to it and put in the exponent. There we go. Sorry about that, kids. It's good for you to see me make mistakes. Then you can maybe learn from them. I never seem to. Okay, here we go. Now, next thing's a couple of questions. Now, I don't know why they put these questions in there, but it's okay. So they want you to say, what would be the appropriate model for the set of graph data? Now remember that we've been looking at quadratics, but that's not the only kind of graph there is. There are linear functions, and linear functions, just like it sounds, that's a straight line. And then quadratic functions are parabolas opening either up or down. Okay? So what they want you to do is look at what you have and ask yourself, if you continued this on infinitely, right? Because they just give you a series of dots. But if you continued this series of dots infinitely, would the shape look more like a straight line or would it look more like a curve? Okay? Now if you look at this one, what's happening to these lines, these dots is they're just dotting further and further, going up and down. So this one looks like a quadratic function because if those dots continued infinitely, then what would happen is you would get a parabola shape. Okay? So let's click on that and see if some of us are right. There you go. Okay, let's look at the next one. All right, should the coefficient of x squared be positive or negative? In other words, would your parabola open up or down if it was a parabola, a completed parabola? Opens downward, so that means it's going to be negative. Okay, and that's all they ask. Now look at this one, however. Now this one, even though this last dot goes down a little, this one, really the best model for this one would be a straight line. See that? And we haven't really talked about the slope of these, about if it's going to be positive or negative, but notice that the line is going up, so that means that this line is positive. Your x would be positive. Okay? So let's look at what would be the appropriate model. This one looks like a straight line, right? It looks much more like a straight line than it does a U shape. And it's going, starting at the bottom and going up, even though that last one goes down a little bit, for the most point it's going up, so that means that it would be positive. Positive up, right? Be upbeat, positive. Okay? And that finished this assignment. So those last two are a piece of cake. Love it. Okay? Now, so you've done this one. We're going to move on into the next part of the chapter, which next time, which looks as if it doesn't have anything to do with this. And I totally agree with you. I don't think it does either. But this uses a lot of information from what we've done in the past, so it shouldn't be that challenging for you. All right? There you go. Do your homework. Have fun. And I'll talk to you soon.